Right. So the first question, sir, I would like to ask you is, so what inspired you to study and model the COVID infection process?
Yeah, it's a very unusual story, and according to it, almost by chance. I don't quite work in this domain. In fact, but I was put in a committee by Department of Science and Technology last year, whose task was to seek proposals for COVID models and choose or synthesize them into one single super model, which can be used for predicting COVID trajectory in the country.
Right.
And it was a 10-member committee. It was a 10-member committee. I was just part of it. We went through the usual process. Professor Vidyasagar was the chairman of the committee.
Mm-hmm.
And we sought proposals, we discussed them, shortlisted 3 of them. And when the time came to synthesize them into one single model, what we wanted was to check if those models that we had shortlisted are able to provide scalable trajectories. That is, at the shortlisting stage, they had given their trajectories, a prediction of trajectories for 1 or 2 cities, which seemed to work well. So
Right.
then all the models ran into problems, frankly. One was simply unable to scale because it was agent-based models, which for one city it had something like 20 million agents.
Right.
Scaling it to the country level became enormously difficult.
Right.
Second one also ran into a problem because they were unable to estimate the parameters values for the country correctly. They were able to get some parameter values for a city or 2 correctly. And the third one actually was an inventory projection. So it was using the output of the first 2 models. So when the first 2 models failed, then there was really we did not have anything left.
Right.
So that's when some of us felt that let's see if we can come up with something. We basically used the second model, which had the parameter estimation problem, because we felt that this is a promising model. In fact, it was a model called SAIR model proposed about 20 years ago.
Right.
And that was being used. So we just looked at that and saw.
Right. So I think also, while reading the paper that was written by you and your colleagues, you also talk about the SIR, suspected, infected, and removed model, which has been traditionally used for predicting infectious diseases.
Mm-hmm.
So, but then the gap which was identified in that paper was that asymptomatic cases were not a part of this model. So you wanted to take this and expand it.
Well, no, asymptomatic were handled by this model called SAIR model, which we also describe in the paper, which specifically takes care of asymptomatic cases.
Right. So, but according to you, what is the impact that asymptomatic carriers have in as of now?
Yes. Yeah, asymptomatic carriers continue to infect others, but since they are asymptomatic, they don't get detected.
Right.
So that's a challenge here. But we realize there is one major problem with this. So SAIR model divides infector into asymptomatic and symptomatic subgroups.
Right.
And it assumes that symptomatic group is known, the size of symptomatic group. But in reality for COVID, that's not true, because even if you look at tested positive, a very large fraction of that are actually asymptomatic. They have been tested positive because of the contact tracing.
Right.
Symptomatic cases positive, you do contact tracing, you find several asymptomatic. In fact, our estimation when we talked to, in fact, Dr. Madhuri Kanetkar, she's the Lieutenant General in Army, she was also part of the committee. And she told us that her observation is that almost 80% of the detected cases are asymptomatic. So SAIR model, therefore, was not quite fitting in.
Right.
And it also had the challenge of parameter estimation, which
Mm-hmm.
thought that looks difficult to surmount. So then, after discussing between essentially three of us, we came up with this alternative model, which we called SAIR2
Right.
at the time. And we it turned out that it was able to scale up very nicely, could do very nice trajectory projection for India. In fact, it predicted already by August end that September will be the peak for India in the first wave. And this was shown to the committee. All the committee liked it, and then this was the one that was finally recommended to the DST.
Right.
And so that was the end of it. But then we continued working on it. And an improved version of SAIR2 is what SUTRA is.
Right. So another question that I have following from this is that, in an interview that you did for a news channel recently, you said that the mutation of the virus could result in differences in what the predictions are and what the reality is. Just if you could expand on that thought a bit more, so then it'll be beneficial.
I'll just take the example that in SUTRA model, when we ran it in January, February, it essentially was, in fact, already in November, it was predicting that by February end, the pandemic will end. Effectively, reach the endemic stage. It never ends. Number of people becomes zero, but it reaches endemic stage. So that was basically based on the situation on the ground then. What changed was that there came this faster spreading mutant, and that really caused the numbers to shoot up. And plus, there is another factor, which was that a lot of people became careless. There were a lot of gatherings in closed spaces, exactly at the time when this mutant was spreading. That combined really blew up the thing. So that is what. So events like that happening, one cannot predict in advance.
Right. Correct. So now, if I go to the website that the team has recently launched, I can find a list of states that are available and the models that are there. They also seem to be giving out very accurate results. Now, based on these results, so what would be your recommendations to people who are in charge of making policy? What do you think we should do to take into account the third wave considerations?
Our question is after doing the studies of various lockdowns imposed by different states. And what we have found is that a light lockdown, which imposes restrictions on too much crowding, gathering, but allows otherwise life to continue, is better than a hard lockdown, where you just open everything for 2 hours. What happens is everybody crowds in those 2 hours, and the whole impact gets lost.
Right.
So that's one. And two, now going forward, lockdowns can be eased.
Right.
The reports have come down quite dramatically. What our model shows is that if you open up lockdown a little carefully, things are not going to go bad. So,
right. So another question that I have following that is, how long does the immunity last for people who are removed from the model? So how long can, say, somebody be safe from the virus after recovery?
there's a lot of debate there. Now, immunity is contingent on, basically, it's given by the antibodies. However, antibodies present or absence of antibodies doesn't necessarily mean that immunity is lost. because there are these T cells which can regenerate antibodies if there is an infection.
Right.
Now, serosurveys or this rapid antigen test, they basically measure the presence of antibodies. So now there are research which shows that antibodies are present in the body for about 3 months certainly. After that, their level starts dropping. By 9-10 months, more or less, antibodies go away. So that's the range for antibodies being present in the body. However, very recently a paper came which showed that the bone marrow had the ability to make antibodies even after 1 year of the infection. Whether those antibodies are enough to fight off the infection is not clear. So there is still a lot of speculation in this domain. The real, leaving aside all those studies, I think the reinfection cases are going to give us a very nice picture of exactly what is the rate at which immunity is lost. Unfortunately, this data is not publicly available.
Right. So from that point, I would like to ask you, if hospitals are conducting studies internally and they want to focus on reinfection, what parameters should they focus on and what data points should they collect so that their observations are robust?
First is that both the time the test should be RT-PCR. Because RT-PCR positive is guaranteed to detect the existence of a virus. And there should be, these 2 positive cases should be separated by at least 3 months. That's again standard accepted definition of reinfection. So, because if your gap is less, it's possible that a trace of earlier infection survives, and that's what got detected by RT-PCR. RT-PCR is an extremely sensitive test. Even a slight presence of virus is detected. So that's the what the hospitals should be looking at who are interested in finding reinfection cases. 2 RT-PCR positives on the same person, separated by 3 months or more.
Right. So my last and final question to you would be, what role can technology play in this pandemic to sort of make predictions and to reduce the burden on the healthcare system? Because there are many decision-making tools available, and they can support the physician, but somehow they're not considered to be accurate enough. They're not considered to be. They have some of their own limitations. But I would like to hear your take on that.
No, I'm not really I'm not very conversant with these tools which are decision making. They provide help in decision making, and so I won't be able to comment how good they are or what role they can play. It's certainly the case that at the very least they can augment a physician's ability to check if there is a strong yes or strong no. Perhaps then the physician doesn't have to look at those cases, and if there is something in between, then physician does step in, so it reduces the burden. Now, at what level are those cutoffs to be placed? That entirely depends on the ability of these tools to provide very accurate predictions.
Right.
At the same time, there are so many other ways of that technology can help. I mean, I think this whole oxygen crisis that came up for a period. There was less of a production problem, more of a logistics problem. And if we had good technology backup for the logistics, on real-time tracking of where the need is. Every hospital, all the usages are online, so there is a dashboard which can tell which hospital is at what level, and also what is their consumption. Maybe hospital is consuming excessive thing. In fact, We did some for the government of UP and found that several hospitals were doing excessive consumption because being careless or some other way. And then they just by this observation, they could reduce their consumption. So a lot of these things can be very easily facilitated by technology. We don't have that on a platform, but I think going forward, we must have that. Another crisis like this, we should not be left in kind of situation we were.
Right, right. Well, on that note, thank you so much, Professor Agrawal, for joining us for the short interview and for sharing all of your insights. We will be posting this interview on social media, so we hope to reach as wide of an audience as we can. And congratulations once again on the success of the Sutra model. The hashtag itself, I think, has at least 3 or 4 posts on the model itself every day. So I think it's a big achievement. And congrats to you and your team. Thank you. Thank you for your time.
Bye.
Bye, sir. Pleasure talking to you.